Hello, everyone. You are welcome to today's meeting. And in today's meeting, we are going to continue from where we left off. Okay, in our previous meeting on the topic statistics. So in lesson 3. So today will be lesson 4 of statistics. Okay, and this was the question. Okay, the table below gives the ages of 15 football players invited for a camp. Okay, if the average, so obviously you can read. So that's what we have here will be is the question. Okay, with the table here. So solution, what you write first. And before you can find the mean, you can find whatever, you need the values of M and N. And the question specifically asked you to find M and N. So even if the question didn't give you A, okay, meaning this information was up here. Okay, the first question just asks you to calculate correct to 2 decimal places, these two. Okay, you have to go through the values of M and N before you can do that. So indirectly, the question is guiding you. That by the nature of the question, you are being guided as to what to do. Okay, so before you can find, once you have 2 unknowns, we have to give you either directly or indirectly, okay, 2 information or 2 relationships that will help you generate an equation each. Okay, so 2 equations to solve for the 2 unknowns. And the first one will come from, because we know the total number of players, we know that if you sum, okay, the sigma F here should always give you 15. And also your average, which is what the mean, should also, okay, give you what, 15. So this will be the information that you rely on. Okay, so A, before you can do all that, you have to, okay, do your table, because you know that the mean will involve sigma fx, okay, and equally involve what sigma f. So you go and add to your table sigma fx, because already these 2 columns will be there, only that you label this as x and this as what, f. Very important. Okay, then you come and sum. This will involve M and N. This equally will involve M and N originally. So here we know, but the summation of F, you are told, is 15. So this means that what you have here, okay, must really be equal to 15. So you use this one to set up your first equation, which will give you M plus N is equal to 6. So you call it equation 1. And the second piece of information here, which is about the average. Okay, you are told that the average is 15, and you know that the average is what the same as sigma fx over sigma f, and this is equal to what? Okay, 15. So now what is your sigma fx? Okay, after doing all that you have here, you know how you can multiply together. Multiply these two to get what you have here. So as for how to generate this, it shouldn't be a problem. Okay, then if you sum the constant, which will give you 129. You have one, okay, term in M, which is 14M, one term in N, which is what? 20N. You add that one as well. Over, okay, and please don't come and divide by this, because you know that this should be 15. So automatically you substitute 15 there, because indirectly you've stated that here this is equal to 15, so you can substitute 15. If you like, you can also substitute this, but that will mean more work, because if you want to substitute this, you will write more, obviously. Okay, and anytime in your presentation, anytime you write more, okay, it means you are consuming more space. Okay, and therefore you are using more time. So if you do so, your presentation will not be ideal. Anytime I mention ideal presentation, and we are looking at the presentation that will save you time and equally was space. So at this point, what do? You cross multiply, and that gives you what we have here. You arrange, okay, or rearrange, I should say. Collect the terms in M and N on one side, and the constant term on the other side. So my 14M plus 20N should be equal to, then I move this one to the side. So I'll get 225 minus 129, which gives me 96. I cannot label this. In fact, you can label this equation, but you shouldn't. Any equation that you label, make sure the equation is in its reduced form if you can reduce it. And obviously, this equation can be reduced, and we can divide through by 2. So after the reduction, you label the equation. And at this point, okay, this is how you go by your presentation. Okay, just write from 1. Don't go and write from equation 1. Once this one is circled, in math, when you are reading it, you read it as equation 1. So if I write from 1 circle, and if you had your labeling in brackets, this in bracket, you should use okay, bracket here as well, because some of you label in bracket. So you should be consistent in whatever that you have here. So at this point, we are going to write from equation 1. That's how we read it. So don't write the equation. And comma, this will always be too short to take a line. So write comma, then go and make your whatever variable that you want to make the subject. However, remember I've told you, anytime you are solving two equations simultaneously, ask yourself or listen to the equations. The equations will tell you the best approach to go or the best method to use, be it elimination or substitution. Elimination will be best when what you want to eliminate, okay, they have the same coefficient, neglecting the signs. But if I want to eliminate m, okay, they don't have the same coefficient. So it means I have to multiply, okay, by a constant, more work. Okay, n, multiply by a constant, more work. So in this case, elimination will not be the best way to go. Let's see whether substitution will be the best way to go. Substitution will be best when the variable that, or the letter that you want to make the subject, okay, after making it the subject, will not involve a fraction. And here you can see that I can make m the subject, no fraction, n equally no fraction. So when the coefficient of whatever you want to make the subject plus 1 or minus 1, it will never involve what, a fraction. So here substitution will be the best way. So that informed my decision to go, okay, to equation 1 and make one of them the subject. So I made m the subject. Okay, so I wrote m is equal to, then I move this one here. And like I always do, anytime I take one equation and work on it, okay, I will give or attach A, B, C, letters to the original names, okay, of that single equation that I worked on, so that I will know that this is a baby of equation 1. In case of trouble, I can trace the parents and redeem myself. Okay, otherwise you can label it equation 3, equation 4, provided the name is not already given. So 1a, and you need to go and put equation 1a into the other equation, which will be equation 2. So equation 1a, just write this, don't write putting, don't write puts, don't write substituting. Okay, between put and putting, if you want to write, you have to write putting. Don't write put. Between substitute and substituting, if you want to write substituting. If you write put, substitute, it's like you are commanding the person who is marking, which you can't. Okay, so make it continuous if you want to. However, I've told you, it's not necessary. Just write equation 1a into equation 2, comma. So wherever you see m in equation 2, you substitute 6 minus n. That gives us what we have here. Okay, you remove the bracket, then you solve for your n. If you solve for n, we are going to, okay, get, okay, n to be, and at this point, when you have a term, you write it again before you divide, n to be equal to 2. Okay, so you label, you need n. Okay, you have to go and substitute. So you have to label, okay, so that you can proceed this way. Okay, equation 3 into the equation that you made, okay, m the subject, preferably, and that is 1a. So comma, m will be equal to, remember we said it will be 6 minus what? N. So 6 minus n, and your n is what? 2. So in this case, you get m to be equal to 4. Then you comfortably draw your conclusion. Okay, all right, so is my point well made up to this stage? Hello, is my point well made?
Yes, please.
Okay, good. Okay, so now we come to what? II. Okay, so don't forget your conclusion. Someone can draw the first conclusion here after getting your n. Therefore, n is equal to this. Therefore, m is equal to, so that one will be you drawing your conclusion separately. But because the question asks you to find m and n together, it is better to draw your conclusion together. That's not to say that if you separate your conclusion, you'll be marked down or you lose any marks. You will not. Okay, only that is ideal. Okay, so in this case, in actual fact, I meant mean deviation. Obviously, you can see that the question has given you the mean. you get it? So if I ask you to find the mean, it means indirectly. So indirectly, you could have stated here straight away that the mean is equal to 15 because the question told you that the average is 15 for this particular data. Okay, this is not the assumed mean. This is the actual mean. So it means if you go and do your calculation, you still have to end up getting the 15. So I should have taken the mean. It should have been mean deviation rather. But per what we have here, it is what mean. And Kobe, Where did you get your mean deviation from? Because you did mean deviation. I don't know whether I have forgotten. Did I ask you to do mean deviation? Because I remember I said do question 7. Okay, all right. So if I did not, then it means that was not supposed to be part of your solution. And now you know that you shouldn't leave any space or spaces between your steps. Okay, so at this point, okay, finding the standard deviation, we know it will be root of, you quote the formula, and the formula will tell us that you will need, as for sigma fx over sigma f, we know. Okay, so we need sigma f x squared, and that is the column that you have to attach. So you come and attach that column, and that is here. Okay, now, once you know your m, you know your n. I told you yesterday that you can write it here rather than going to generate a new table altogether. So write it here and fill in your unknowns. So this will be 56, this will be 40. So now you can sum everything here, which will give you 225. Okay, and once you know this, you can multiply the actual values. This will not involve any of the letters because you now know the actual values. So this is what you are going to get. After that, after quoting the formula, the rest becomes trivial, just calculator work. Okay, and you end up getting 4 dp first. However, remember I told you, in terms of age, it is convenient to approximate to 1 dp. Okay, and this will give us 3.0, okay, years, and that is to 1 dp. Okay, any questions at this point? Are we all fine? Is everyone fine? Hello, my professors, can you hear me?
Yes, please.
Okay, and you can see that with this one, I put the therefore here, so meaning my conclusion is embedded. Otherwise, if there's no therefore here, you are supposed to come and write therefore. You should always conclude, rather than you underlining your final answers. Okay, take notes. Okay, so if you don't have it, yes, please, I'm here.
And please, the question says it should be in 2 decimal places.
Oh, really? Did I see, was there any approximation? Let me check. If the question gave you an approximation, then it means, oh, okay, then it means the first one too, I should. Okay, so in that case, then this can be a very good question. In fact, this can be a question on its own. I can ask you to find a mean to 2 dp. Okay, because what you were given was not 2 dp. Okay, so quickly, let me add that. Okay, so I didn't underline the salient part, so you can see what happened to me. So obviously that can happen to you. So this one, it wasn't intentional, it was a serious omission. Okay, so let me see if I can do the needful. So I should have underlined this to protect my marks. Okay, very good for drawing my attention to that. So assuming you were asked to find the mean, the question just asked you, then it means in this case, the mean will rather be 0.00, 15.00 to 2 dp. If you leave it as 15, you will be marked down. So it will be 15.00 to 2 dp. And this one will give you 0.3, okay, to 2 dp. All correct. Is my point well made?
Yes, please.
Okay, all right. So let me see if I can clear this and do the needful. Okay, I think that's the only thing that can go. Okay, because I saved it originally. So I cannot clear it until I go back to the normal view. Okay, so this will be it. Now, I believe you have your graph books with you. Do you? Remember, we were supposed to do the graph yesterday. Time didn't, in fact, electricity didn't allow us, okay, to do that. So that's what we are going to do, okay, today. Most of what will be done today will be, so it will be 0.00, okay, years. And that will be 2 dp. Okay, all right. So now to the next, okay, question. Okay, I think this is what we have here. I cannot go to because I will be using the straight edge. Okay, so let's look at it. We are first of all going to learn how to draw the histogram. Okay, then we'll see how we can use the histogram to predict, okay, or estimate what the mode. Usually, anytime you are dealing with graph, okay, whatever that you'll be asked to find will be an estimate or it will be an approximation. Okay, because we know you can, okay, start with a certain error due to your material or even introduce a little bit of human error. So for graph work, usually we give room for, okay, or we give allowance for a certain margin of error. Okay, so your answer shouldn't be always that precise, accurate. Okay, it should fall within a certain allowed, okay, values. Okay, so now, this is it. Anytime you are asked to draw a histogram, usually we'll say that a histogram is basically a graph, okay, of your frequencies against the class boundaries or your frequencies against the class midpoint. But I usually use the boundaries. In some books, you see that they use the class midpoint. Okay, but I will be using the boundaries. Okay, I find comfort in that. Okay, so in this case, this is what we are going to do. Okay, with this one, I have the solution there, but not the graph. Okay, the table itself. So you know that here you have a raw data and you've been asked to construct a table, a frequency table using these what class intervals or classes, 10 to 19, 20 to 29. So it means when you are constructing your table, that's how, okay, so you start with max, okay, then it will be 10 to 19. You use the pattern of interval given in the question, and you know that you end at what, 89. Okay, so at this point, before you can get your frequency, you know you have to tally, okay, before you can get your exact frequency. Okay, and again, after tallying, you will get your exact frequencies. And because we are going to draw the histogram, remember I said you will need your class boundaries because the histogram is basically your frequencies against what the class boundaries. Frequencies against the class boundaries. So we need the class boundary. That's why you can see the class boundary column. So these two will help us draw, okay, the histogram. And let's see the order of the question. Irrespective of the order of the question, I am interested in the histogram. So it's like the A is done, the B, A will be the table, okay, and B will be, okay, the histogram. Okay, please, are you ready with your graph? Okay, the way you people are quiet, I suspect some of you don't have your graph books with you. However, if you can follow, but it's better if you, okay, take part. Okay, sometimes you looking at it, you might think you are okay. But when you are faced with a real situation, then you see what really it entails. Okay, so at this point, this is what we are going to do. Okay, let's look at our maximum. So because we need to draw the X and Y axes. Okay, the Y axis will be our frequency axis. Okay, and the X axis will be our class boundary axis. Please take note. So frequency will be here and what? And the boundaries will be here. However, let's look at what? The boundaries. The boundaries we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, however, in terms of your, what do you call it? 2 centimeter boxes, we have how many? We have here, we have 10 of them. But meanwhile, here you have what? We said we had 8. So it means you have enough room to accommodate that. Let's come to the frequency, okay, column. The frequency, indirectly, we are scaling. Oh. We are planning how to scale. Okay, so you come to your frequency, the minimum is what? 1. And the maximum, okay, is what? 12. So you know from here to here, okay, you will get 12. If you look at it from that perspective, that's okay, 2 centimeters to 1 unit, you get 12. However, I will advise, okay, you don't let your entire graph area be consumed, okay, by, I mean, your grid area that you have here, be consumed by your graph. Leave a space up here because every graph is supposed to have a title, okay, and also a scale, apart from the fact that the others must be labeled. So you always have to give room here, okay, for your title because I realized I have 12. If I erect that, okay, bar that has the height of 12, then where I'm supposed to write my title is gone. And all that you are going to do must be done in the grid area. So it means your title, everything. And everything here too should be in pencil. Okay, avoid using ink on your grid area. I repeat, avoid using ink, okay, in this area. Never, because you can get something wrong. And when you get it wrong, you can easily erase if you use, okay, a pencil. So quickly, this is what we are going to do. I know that in this case, 1 centimeter, so 2 centimeters to 1 unit, okay, might not really help. So let me see, 2 centimeters to 2 units, 2, 4, 6, 8, 10, 11, 12. Okay, that would be okay. Okay, in the sense that usually if your scale covers more than half of the grid area, okay, then we deem that as a suitable scale. Should I come again, or my point is well made? Okay, so
okay, it's fine.
I should come again. I said, here you are going to choose a suitable scale. A scale was not given. And I said your scale is suitable, is deemed suitable. If, okay, after drawing your graph covers, okay, more than at least half of the grid area. So if, let's say, I use 3 centimeters to maybe, let me use 2 centimeters to 3 units, it will be 3, 9, okay, 12. Okay, sorry, 3, 6, 9, 12. So I will end here. And you can see that if I end here, this is the area that my graph is going to cover. And it is not, okay, up to half of it. So it means though I have scaled, but my scale is not suitable. It's my point well made. So in this case, you are going to get maybe 2, 4, 6, 8, 10, okay, 12, half. Okay, I will bring it up a little to create room down here. So this is what I'm going to do. So I am going to draw my others. Okay, so quickly, let me go and draw my others. Okay, so I want to indicate my, usually you want to write down. Okay, but I will bring it up a little. So I'm going to draw, I hope you are following.
Yes, please.
So I'm drawing my x-axis first. Okay, so let me indicate my x-axis. Okay, should I choose another pencil? I think the red will do. Let me continue with my red. So I have this. Okay, indirectly, this is my x-axis. I need to go and draw my y-axis, and this time around. Okay, you can see that here there are no negatives. So you don't position it the traditional way, the middle way. You do that when you want to create, okay, or you are dealing with positive and negative values. So in this case, my y is going to be here. So let me even do this. Okay, all right. So immediately you draw, okay, indicate your x, very important. No matter how beautiful your graph is, if the others are not labeled, it is 0. Everything will be 0. So this will be your y. If you like, you can extend it. Okay, so at this point, this is what we are going to do. We are going to calibrate. Okay, so let's see. I want to use 2 centimeters, and this is what you do. Always, okay, calculate for the class size. Look for the, and in core math, you always have equal class size. It's relative math that, okay, so relative math you have on equal class size. So we'll come, okay, to that when we are dealing with what the relative math statistics. Okay, so here, calculate your class size. And remember, we said the class size or the class weight is calculated in terms of what's the boundaries. So 19.5 minus 9.5 will give us what? Will give us, if you're able to get the class size, you are good to go in terms of 10. Your, it will give you 10. And this is what you do. The advice is always, okay, your scale is supposed to be what? 2 centimeters to your class size. So in this case, it will be 2 centimeters to what? 10 units. Is my point well made, or I should come again?
It's well made.
Well made. Okay, so now, okay, this is it. And you can see that if you are supposed to start from here where the others meet, it will be 0, 0. That's the origin. But the value here is not 0, it's 9.5. Your first value that you want to start with is 9.5. So that's what I'm going to do. So you indicate your 9.5 here. you calibrate 9.5. Okay, very soon I will do something else. Okay, there. Then from here to here again, okay, you know, always, immediately you get it, you have to be using your distance. So you said 2 centimeters to 10. So you keep on adding 10. So if you add 10, you get what? 19.5. And you can see that as you continue doing that, you'll be landing on your value. So unfortunately, I cannot write everything. Okay, so but you will write all the boundaries. Is my point well made?
Yes, please.
Okay, so that is what you have there, or whatever you have. Okay, so now I've done the calibration for the X. I need to do the calibration for the Y, which will be the frequency. So in this case, don't forget to write what you are using the class boundary. So write class boundaries down here. Okay, and you come and write frequency here as well. Oops. Okay, you write frequency here. Take note of that. Okay, you can turn and write it, okay, the way you want to. Unfortunately, I cannot. Okay, so here, what do we have? You do your calibration. We said 2 centimeters to 2. So this will be 2, this will be 4, okay, this will be 6. And when you are calibrating, make sure you draw through the line, you indicate. Don't assume the lines are, okay, what you are using to calibrate. Okay, so 8, 10, okay, 12. So this is what we have. Okay, so the first bar, okay, we need to look at the height. The height will be the frequency. So between 9.5 and 19.5, okay, the frequency is 2. So I come here, then, okay, draw or erect my first bar. My professors, are you following?
Yeah.
Okay, so I draw up to what? Up to 2. Okay, and where it ends, it starts here and ends here. And here, you know, histogram, there shouldn't be any gaps between your bars. Okay, so this will be it. And obviously, you come and close it. So this is going to be the situation. So I'll close it up here. Okay, so this will give us exactly what is there. Okay, that's it for the first one, the first class. Your second class, 19.5 to 29.5, the frequency is 4. So it means the height must, okay, extend to 4. So what do? You come and do same here. So you extend this, okay, to 4. Okay, I guess you are doing same.
Yes, please.
Okay, then you go to the other boundary. We said it's 19.5 to 29.5. So the 29.5 to, okay, you draw. Okay, then you come and close it. Okay, then the next one, okay, that is the modal, okay, class 29.5 to 39.5, and that is 12. Okay, so that will take you way up there. Okay. Then you close it as well. Okay, the next one, we are looking at what? 6. That is 39.5 to 49.5, and that is 6. And where is 6? 6 here. So let me, okay, draw this one first before I go and draw the, okay, vertical lines. So from here to here. Okay. Okay, the next one, we are looking at what? 1. Okay, and you know, 1 is supposed to be midway what we have there. So that is 49.52. Okay, so let me also do that quickly. That's supposed to be the 1 meter, 1 centimeter, okay, line. Okay. Okay, and so you continue, okay, till you get to the last one. Is that clear? Okay, so you let me continue. I will do only one example. So, okay, so let's look at the next one will be 8. So you move on to 8. You know where 8 is. 8 is here. So here is 8. So you extend this one to 8. Then come here. 8. Okay, I'll later go and close it. Okay, then, or you let me close it before. Okay, I forget. So you close it. Okay, then what are we looking at? The next one is, okay, I think we have 2 more, 5 and 2. Okay, so 5. 5 will be, okay, here. Okay, so 5 is going to be, where is my, okay, 5, this is 6, so 5 will be midway. So you're, okay, then you close it. And the last one is 2. So I'm also going to draw that of the 2. Okay, 2 again. Okay, then I go and close it. I close the 2. Okay, I'm left with the 5 to closing the 5. Okay, so after this, please take notes. Okay, these are the low-hanging marks that you shouldn't lose. Okay, the answers must be labeled. You have every graph is supposed to have a title. So this will be a title. Always the graph that you are asked to draw will guide you. So here, if you go back to the question, let's go back to the question and let's see what we were asked to. So draw the histogram for the distribution. But if you know the exact distribution, and indicate, because here you know that you are dealing with marks. Okay, so your title will be a histogram for the mark distribution, as simple as that. Okay, and your title must be in capital letters, always above. Take notes, always above. Okay, somebody is interfering, so let me mute the person. All right, so we are going to get, okay, a histogram. Your title up here, histogram in capital letters. Okay, for the, okay, mark distribution.
Mr. Hackman.
Yes.
Please, is the origin 0? Oh, is the origin 0?
Do something, don't worry.
Okay.
I'll come to that. Okay, then you neatly underline. So you underline with your straight edge. Okay, please take note. Your graph is also supposed to have a scale. Okay, is the title that should really be up there. As for your scale, usually we write it here. But if you don't have room here, you can write it anywhere else that you have space for it. but your title must always be up. You cannot write your title anywhere apart from up. Is that clear? Okay, so our scale. So you come and write your scale. So scale, you have room here. And your scale should not even be on the same line as your title. It should also always come below. Okay, so scale. And you write just the x-axis. Okay, x-axis you use, okay, 2 centimeters to 2 units. So x-axis you use 2 centimeters to 10 units. 2 cm to 10 units. Is that clear? And the y-axis, so y-axis, okay, we use 2 centimeters to 2 units. Is that clear? Okay, and please don't write 2 centimeters to 10 units on the x-axis, 2 centimeters to 2 units on the y-axis. Just write x-axis that, y-axis that. Okay, if you write on D, okay, the on D will be the extra thing that you write. Okay, the title is supposed to be, if you were asked to draw a histogram for the distribution, in actual fact, it's supposed to be a histogram for the distribution. But if you know the exact distribution, you attach. So here, you know that you are dealing with marks. So a histogram for, okay, the mark what distribution, as simple as that. A histogram for the age what distribution. You get a point, Fedios. Okay, so that will be it for our graph. Is everyone okay? And the histogram for that matter. Is everyone fine? So the title, okay, the marks, okay, protected. The scale, the marks was protected. And I've told you that your calibration here, you write everything. Okay, I mean, you write all the boundaries here up to what? The last one is 89.5. So 89.5. Okay, for obvious reason, if I write it, you won't see. Okay, because of how the size of, okay, what I have here. So in this case, this is all that you need to do. Okay, at this point, please don't leave your graph. Okay, you can see that per your scale, this first 2 centimeters, you said every 2 centimeters, okay, should give you what, 10. Meanwhile, the first 2 centimeters, is it giving you 10?
No.
It's giving you 9.5. So that is not conforming to the scale. However, if you come to this, you know that when you are calibrating your Y, okay, so you calibrate this way. Where is this? So if you are calibrating your Y, you calibrate on this side, your X, you calibrate down. So in actual fact, this is 0. If it is any other number apart from 0, you have to write it. Okay, but here I know for my Y is conforming. 0 to whatever, but this one is not conforming. Whenever you have this situation, you break the graph at that point. So you move in a little with a diagonal line, you continue with a diagonal line downwards, and you move a diagonal line upward to meet your x-axis. That's all. Is my point well made?
Yes, please.
In certain questions, okay, if you can give you a question in such a way that, and usually, okay, for me, because of the nature of such questions, I advise students, instead of breaking the graph, we could have started the first calibration here with 9.5. But if this value here is not 0, you have to write. So in that case, you write 9.5 here, then your next one, which is what, the 19.5, and what have you. So the region that you broke, okay, indirectly, it's like you push it to the side. It's taken care of. So take note of that. If you do that, then there is no need for you to break any graph. So I usually start with that. I will start with, okay, my 9.5 here, but I wanted you to know, okay, that's why you do this or why you see this in what? In your textbooks. Okay, so if the first is not conforming, you have to do this. And you just go in a little, you come down, okay, then you move up. Where you started on the x-axis. So you come down a little and end on the x-axis. Is my point well made?
Yes, please.
Okay, very good. All right. Okay, so now it means we'll have a perfect score for the graph, and that's let's see whether it had a question number, then it means our solution must be numbered as such. The graph, okay, is B. So on that note, it means I should have stated here that I'm giving the solution for B. So this will be, okay, the B. Okay, and that should be on top. It shouldn't be, it's not part of your graph. Okay, or somebody can equally write B here and write C graph. It's allowed. Is my point well made?
Yes.
Okay, so now, okay, to find the mode, okay, using the histogram. Let's see if that's a follow-up question. Okay, so CI, use your histogram to estimate the mode. And this is how you use your histogram to estimate the mode. First of all, go and locate the modal class. And the modal class is the class with the highest frequency. And you obviously can see that this is the modal class. Okay, because that is the class with the highest frequency, the highest bar. Is that clear? So locate your modal class.
please.
Just as when we were using the formula, we located our modal class. Okay, then this is what we are going to do. Okay, you are going to draw two diagonal lines. And this will be how you draw the diagonal lines. One of the diagonal line, okay, all of them, okay, so one will have, let me put it this way, okay, this as one of the points that it will join, then this as the other point. So this point will come and join the closest, okay, bar, the one that it flashes with. So where it starts, the next bar where it starts. Okay, so you draw your diagonal, but your diagonal should be a continuous line. Okay, then you come and draw another diagonal, and that will also start from here, okay, and end at where the closest point, okay, or the closest boundary. Okay, so I think I can end there. Then I draw this, and these two lines should be continuous lines. You are not done. Where these two diagonals meet, okay, you trace down. Okay, but when you are tracing, you trace with a broken line. You don't trace with a straight line, you know. Okay, in math, anytime you are tracing to read, we usually use broken lines. So I will come. I hope you are following my professors. So usually I will advise students, before you trace, locate the exact point of intersection, okay, with your pencil. So assuming I'm also doing same, I'm locating the exact point of intersection. Okay, then I can now place my straight edge there. It is obvious. Okay, that this is, okay, then I go and trace. Come again.
Please, so we draw the lines from the top to the, where it touches one of the bars.
Yes, always. So all the two corners of what, or your vertices, okay, of the longest bar, okay, your diagonal line must pass through them. You get it?
Yes,
okay,
please.
so this is what we have. So at that point, you are going to trace down. And when you are tracing with your broken lines, space up. You don't give mass for the number of broken lines that you have there. So space up, okay, so that you can quickly go and, okay, cut the X. Okay, so we go and read. And because your graph is scaled, okay, you should know the size of each small box. And therefore, you should be able to predict the value that is here. Is my point well made? So we are now going to indirectly, you will have all your values there. So this one was 19.5. Okay, 19.5. This is 29.5. Am I right?
Yes, please.
And this will be 39.5. Okay, so your mode will be between 29.5 and 39.5. Obviously, that is the situation. So each small box here will be what? If 2 centimeters is equal to 10 units, each small box will be what? Two centimeters divided by 10, right?
Yes, please.
Which will give us
0.2.
0.2. So it means each small box is 0.2. So here is what we said this is 29.5. So plus 0.2. Okay, so you know it will be 29.5 plus 0.2 will give you what? Okay, you can be smart anyway. Okay, you know that if this is 29.5 midway, you've gone beyond the midway. So you start adding your small box from the midway. Okay, only that, yeah, I want us to deal with it that way. Or, okay, what do we have? So let's count how many small boxes. How many small boxes? From mine, okay, let me use my 1, 2, 3, 4, okay, 5, 4, 6. I have 6 small boxes. Okay, so I'm going to have 0.2 times 6. Okay, the value I added towards 29.5. Is that clear?
Yes, please.
Okay, so give me the value and let's go. And that will be my mode. So I'm looking at, okay, now I can go. Let me see whether I created the next page for it. No, I did not. So I have to squeeze it somewhere here. So CI. Okay, from the graph, I will have my mode, okay, to be equal to. I'm waiting. Okay,
From my graph, it's 36.
36.
Yeah.
Okay, no, that is. Did you ask how did you know? Okay, you know from your calibration. Okay, we've determined that it's small box, and once you have it cutting your x-axis, you should be able to do the reading. That one I'm not supposed to help. Okay, from Form 1, you've been doing graph work. Okay, even in integrated science. Okay, so how to read shouldn't be a problem. So this will be how to find what's the mode from the histogram. So in actual fact, okay, in terms of the formula, the difference here, okay, this distance, okay, is what we call change sub 2. The distance here is what we call in the formula change sub 1. Is that okay?
Yes, please.
Okay, but here you don't. Okay, so remember I told you one of the questions that we use the formula to find the mode. Okay, I'll ask you to draw the histogram for it and use the histogram to predict the mode and see whether the mode will be the same. If they are not the same, and okay, we'll check whether the variation is what's huge. Usually, if they are not the same, then the variation shouldn't be huge. It should be it should be insignificant, very close, because this one is the estimated value. Okay. All right, point well made. So now we all know how to draw the histogram. Is that not it?
Yes, please.
Okay, very good. Okay, so we'll move on to the next question. Yes, please.
What does the title say?
What's the title again?
Yes.
Hey, how many times should I say that? Fadayo, is that you?
No.
Okay, I said usually let the question guide you to indicate, okay, or state your title. So draw a histogram for the distribution. So in actual fact, it will be a histogram for the distribution. Okay, but if you know the exact distribution, you can be exact in your title. Okay, and it will be a histogram for the, here you are dealing with marks. So it will be for the mark distribution.
Okay.
Okay, so if this age, a histogram for the age distribution. All correct.
Yes, please.
Okay, good. All right, so now we can move on. Okay, so let's move on to the next question. Okay, so here I picked this question because I want you to know that it's not only group frequency distribution table that you could be asked, okay, to draw a histogram. You could be asked to draw, though usually, okay, we draw a histogram, okay, using group frequency distribution table. That's why I said in the definition for the histogram, I said it is what? A graph of what? Your frequencies against the class boundaries. So if you don't have groups, how then do you have the, what do you call classes? For you to have class boundaries. So don't worry, you can equally draw. What is important is that for histogram, when you are drawing your bars, there shouldn't be any spaces between the bars, that's all. So with this one, okay, when you are drawing, you can use 2 centimeters, but when you are labeling, just like assuming maybe this one, you were asked to draw a bar, okay, chart. If you are asked to draw a bar chart, the first one, you draw your first bar and label 2, okay, 8, or write 2 below 8, okay, or midway. Then draw your second bar, you leave a space. But anytime you are drawing the bar chart and you are leaving spaces, don't let your space be as big as the bars that you are erasing. Okay, I should say you are erecting. Okay, don't let this, so assuming maybe use 2 centimeters for the weight of each bar, you cannot use 2 centimeters for the spaces between them. You either use 1 centimeter or something below 2 centimeters. Is that clear?
Yes, please.
Okay, so the same way, the difference is that this time when you are drawing your bars, there shouldn't be spaces between them. So if you erect your first bar, so let me see whether I created a graph for it. Then I will use, okay, I think I did. So I think I can equally state that here with that. So if I erect my first bar, so I will, my first bar, assuming I've drawn my x-axis, okay, indicated my y-axis. Okay, so my first bar, assuming I started from here, 2 centimeters. So this is giving me my first bar, and that is 2. No, what is the bar? Let me see the name of the bar. Is it 2? Okay, it's 2, 3. Okay, so that's it. Okay, so this will be 2. The next one will be close to 8, and the frequency, the height will be 14. The other one too, it will be close, then that will be, you label it midway, and that will be 3. Okay, the next one will be 4. Okay, however, if you are drawing a bar chart, okay, that one, this you draw, and assuming this is your x-axis and your y-axis, when you erect the first one, okay, which will be for 2, you leave a space, then you come and erect the second one, which will be 3. So then you leave a space, the same gap, okay, then this will be what, 4, and what have you. Is my point well made?
Yes.
So you can equally draw a histogram for ungrouped frequency distribution table. Okay, just as you can draw for that of the group, only that usually you'll be given a group frequency distribution table. So on that note, let me see the next question. Okay, so this question again, I am interested in the histogram. So I believe you should be able to draw the histogram, okay, for this particular one. Okay, here you change this one. So first of all, let me see whether I add okay, so I have this one there. So no, I don't think that's it, because I didn't see, okay, what do you call it? I never saw 10 to, I saw 50 to 54. So there is a mix up somewhere. Let me see whether, okay, so this is not for it. Okay, no problem. I think this one I said I wanted to explain. Just explain, okay. So here, you'll be dealing with the boundary. So after stating your mass chord, which will be in the column form when you are drawing your table, okay, then, okay, with this one, okay, then after that, your number of students, your frequencies, you will need it. Okay, then you also need your class boundaries, because you are going to draw the histogram. And histogram will be your frequencies against your class boundaries. So your class boundaries, I've told you, this is core maths. So in core maths, okay, usually your diagonal differences will be 1. Okay, so take note, it will be 1. If your diagonal differences, okay, 2, then it means if you divide, you get 1. So you subtract 1 from all the lower class boundaries, and you add 1 to all the upper class boundaries. Please take note, now you could be tricked. Okay, so because usually you know that it is 0.5, immediately you see it, you'll be subtracting 0.5, then adding 0.5 without even checking whether the diagonal difference is 1. That will give you the 0.5 because you divide by 2. So always check at least maybe the first 2 diagonal differences in core maths. Always check. So if the first 2 1, then you know that you subtract 0.5 and add 0.5 to the lower and upper respectively. Take note of that. Okay, so here you know 11111. So this will start from 49.5 to 54.5, 54.5 to 59.5. So that will be your boundaries, and that will be what you use in calibrating your X and that of what your Y. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. Okay, what do you call it? Should I say yes, 10 classes. So let's go back and let me tell you something. Okay, here, I think that's why I left this, because I wanted to let you know that situation, though I have mentioned. Okay, how many 2 centimeters boxes do you have here? Ordinarily, the traditional graph, you have 10. Is that not it? You have 10, am I right? So assuming,
please.
okay, assuming in this case, you start from your 49.5, okay, and up to, you see that your 10 will not go there. So you have to move. So for me, to avoid this trouble, okay, though I usually count my classes before, okay, I think before writing, but I will always let my first one come here. So my 49.5 will rather be here. I will never break my graph. Okay, because that in itself is time taking. Okay, so in that case, what do? You start your 49.5 here. Then your next one, you look at the class size. Let's go to the class size. What was the class size? Is that also 10? Okay, that is 5. Is that not it? So your scale will be 2 centimeters to 5 units. Remember, I've told you, let your weight, okay, guide you to get your scale for the exercises. All correct. Is my point well made?
Yes.
Yes, please.
Okay, very good. Okay, so very soon I'll expose those who don't have
Yes,
a
please.
graph sheet. I will ask you to draw the histogram for me right away, very soon. Okay, for this particular one. So if you don't have graph, I won't get your work. Okay, I think, okay, this will be your assignment in the stead. Okay, so no, this one is a cumulative. So cumulative assignment, but let me move on. I will pause here. Okay, we've done an hour. We'll go and have our water break, maybe about 3 minutes. Okay, water break. When we come back, then we go and look at what's the cumulative frequency curve. And very likely to see it this, okay, WASI, cumulative frequency curve, what we also call the ogive. Okay. Okay, so you are welcome back from the water break. We are going to look at our next curve, okay, or graph, which will be the cumulative frequency curve, what we call the ogive. So if you don't see cumulative frequency curve and you are asked to draw, okay, an ogive, okay, it's the same as the cumulative frequency curve. Don't say you were not taught. Okay, take note of that. So at this point, okay, we need to find the value of y before we can go and construct the table. So how do we find the value of y? Remember, there is only one unknown. So it means there should be either a hidden, okay, information, just an information or direct information given to help you find the, what do you call it? Okay, for you to get what? Your y. How do we find y? My professors, are you there?
Yes, please.
So I'm waiting. Oh, someone should guide me. How do we find the y? What information? Okay, Bene, Prophet Benedicta.
Please, you add the frequencies and you equate to 500.
Perfect, as simple as that. Okay, because you know that you are told that the one figure that you know here is about the frequency. So it means likely that's what you are asked to use. So the sum of everything there should give you. So I'm waiting. So if you do that, what will you get for the y? So let's do it together. I think we are going to do it together here. So A, we are going to get, so solution, okay, your table will be there. So you have, okay, you create your column. So let me use this just to save time. Okay, so what are we going to have? You are going to, and the sum of everything here should give you what? 50. So we know that, so let's say 500. Okay, so if you come there, okay, I think we can even do it mentally. So in actual fact, what we are going to get will be this. Okay, so we'll get, let me see, 40 plus 28 plus 40, sorry, 10 plus 28 plus 40 plus 92 plus 60 plus 90 plus 50 plus 30 plus 15 plus 5 plus y should be equal to 500. So you add everything, okay, then you subtract it from 500, and that will give you your y. Okay, so in that case, okay, let me see. This originally was, okay, y plus 60. Okay, so 40 to 49, I can use that to predict. Okay, 40 to 49, it was y plus 60. So if this is 140, then it means y was what?
80.
80. Okay, so please take note. So if you do that, you get y. Once you get y, then you can come and construct. And for the cumulative frequency curve, this is all about it. Remember, we said the histogram is a graph of what? Your frequencies against the class boundaries. However, okay, for a cumulative frequency curve, it is a graph of your cumulative frequencies against the upper class boundaries. Against the upper class boundaries. Only the upper class boundary. The other one, we use all the boundaries, both the lower and the upper. But for the cumulative frequency curve, it will be the upper class boundary. However, usually we won't say that upper class boundary. You will see max less than. Okay, if you are dealing with max. If you are dealing with age, you will see age less than. Okay, so for every cumulative frequency table, okay, apart from the two columns that will be given, the other two columns that you add will be the max less than column or your category less than column. So if we are dealing with max, it will be max less than. If we are dealing with age, it will be age less than. Age less than what? And you can see that it will be the upper limit all along. So 9.5, 19.5, what have you? That's what you have here. Then the next column automatically becomes your cumulative frequency. Unlike the histogram, where one of the information that you would need, okay, is directly given because it's frequencies against class boundaries. So this is directly given. It is the class boundaries that you need to go and add. But with this one, the frequency given, you won't use it directly. Okay, you will use it indirectly and you use it to find the cumulative frequency. And the cumulative frequency, this is all that you have. This will guide you. That's the more reason why we don't write upper boundary. What have you, but we write what the max less than, then you come and state the upper boundaries there. For all the classes, please take notes. For all the classes, that's what you are. So if you take this, check this. We are looking at max less than what? 9.5. Okay, and we are looking at, okay, those who scored max less than what? 9.5. You can see that it will only be those, okay, who scored between 0 and 9. This class will give you, so it's the frequency of 10. So always you start with the first frequency and you end with the total frequency. But how do you get to the total frequency? If you come to the second max less than, you said max less than 19.5. So it means if you score 0 between 0 to 9.5, you are supposed to be part of what? Max less than 19. If you scored between 10 to 19.5, you are still within that what? Less than 19.5. I don't know if you get my point. Should I come again? Hello, my professors, are you following? How we are getting the max?
Again.
Okay, so this is it. You can see we started from 10 and we had what? 38. I'm trying to tell you how we got the 10, 38 values. So this is it. You said max less than. So usually I've told you how to label this. Age less than, max less than. If it's height height less than, whatever category that you have there, less than. But what you state here will be all the upper boundaries, last boundaries. So that would be what you write, okay, correspondingly here. Now, how do we get the cumulative frequency? You can see that just the name alone, okay, will tell you that you will be adding cumulative, okay, cumulative record. We keep on piling. Is that clear? Okay, so in this case, if I'm looking at those who scored, okay, or obtained marks less than 9.5, I will have how many of them? 10. Because this would be the marks for those, okay, I mean, the frequency for those who scored between 0 and 9 is 10. Okay, so if I'm looking at, okay, the frequency for those who scored less than 9.5, then it will be these 10 okay, people. Is that clear? Is my point clear now? If I come to those who scored, okay, less than 19.5, if you scored between 0 and 9, you still scored less than 19.5. If you scored between 10 and 19, you still scored less than 19.5. So if you are here, you are supposed to be counted. If you are here, you are supposed to be counted. So it will be 10 plus 28. So that's what gave us the 38 that you have there. So here, all that you need to do, okay, you keep on summing. So the next one, marks less than 29.5. You come and add 40. So you add all the marks here. So you add 40 to 38, and that will give you 78. I hope I'm clear now.
Yes, please.
Okay, so you keep on adding. And because obviously, okay, if maybe, okay, no one had, okay, 99.5, and I am looking for those who scored less than 99.5, it means the entire class. And that will be my total, okay, number of students, which is the same as my total frequency. So always you start with the first value, the first frequency, and you end at the total frequency. If you don't end with a total frequency, then it means something went wrong here in your addition. So go back and check. All correct?
Yes, please.
Okay, so now we have the information that will guide us draw the cumulative frequency curve. So how then do we draw the curve? That will be the next question. So in this case, this is how the curve must be drawn. Okay, we said it's going to be a cumulative frequency against, okay, your marks less than. So this is where you have your cumulative frequency. That is the y-axis. And your marks less than axis will be here. So now let's count, okay, because this will be your x-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So again, 10. So if I start from here, 9.5, okay, 19.5, 29.5, 39.5, 49.5, 59.5, 69.5, 79.5, okay, 89.5, okay, 99.5, it will go there. So I can start from here. Okay, take notes. Or equally, you can start from here. But if you start from here, you have to break the graph, remember. Is my point well made?
Yes, please.
Okay, so I am going to start, okay, from there, like I said. So let me give you one example of a situation where we'll start from that point. So, oops, forgive me. Let me pick my, oops. Okay. Okay, I'm good to go. Okay, so now I think I can't go down, then it means I have to move up and draw down. Okay, my graph is not that straight, so please pardon me. Okay, I captured it. It seems this one is intruding. Okay, so I will draw my line here. Okay, you just get the concept, you will do the right thing. And that will be your X. Immediately you draw, okay, label it, very critical. So X, you have a perfect one. Okay, and this X here will be your max less than. So you write max less than, though you calibrate. Then let's go to the Y. The Y will be our cumulative frequency, which we also use the scale to calibrate. Okay, so, all right. So this is what we are going to get. Okay, all right, so we are good to go. So this then becomes our Y. Okay, and I've told you write cumulative frequency curve here. Cumulative frequency. Okay, you write it there. And here you write max less than. So the first one is what we said is 9.5. So you come and write, I will write, okay, put 9.5 here because I've told you I want to start from there. Then I don't break the graph. Then 19.5. The next one I calibrate. Okay, that gives me 29.5. Okay, so you continue up to what? Okay, 99.5. Is my point well made?
Yes, please.
Okay, remember I cannot, okay, write all the values, it will be too small. And I've told you for obvious reasons. So now you need to calibrate your Y. And the Y, we look at the minimum value of the cumulative frequency and the maximum. So let's see, if you use 2 centimeters to 10, you are going to get 10, 20, 30, 40, 50. Obviously, you get what? This is 12, so it will be 10 times 12, 120, which obviously you can see. Okay, you have values here way beyond, okay, that. So let's see, if you use 50, it will be 5 times 12, and that will give us that will give us, I want to get you involved. Okay, so please stop. I'm waiting. Hurry up.
600.
600.
It will be what, 600.
Yes, please.
Okay, so you can see that 600 can accommodate the 500, the maximum. So we can use 2 centimeters to 50. Is that clear?
Yes, please.
All right, so yeah, usually a scale will not be given, so you have to choose your. Okay, so in this case, okay, we will have 50, 100, 150, okay, 200, 250, 300, 350, okay, 400, 450, okay, 500. I end there. The other values, I don't need them, so I won't let it waste my time. And you can see that I have 4 centimeter room for my title. So there is still space up here for my title. Is that clear?
Yes, please.
Okay, so now let's go and indicate the point. You know, it's a curve. So just as you know how to draw quadratic curves, okay, and what have you. Once it's a curve, you don't draw joining the point with what? With your free hand, with a straight edge, you use your free hand. So let's go and indicate our points. The first one is what? 9.5, 10. So 9.5, okay, is 10. So 10 will be somewhere here. Okay, this small box will be what? Each small box. What will be the size of each small box on this others? You have 10 boxes here, and this is 50. So how do you get the size of each? It will be 5. 50 divided by 10. Am I right?
Yes, please.
Okay, so that will give you, okay, 5. So each small box is 5. So you need 10. So it means 2 small boxes. Unfortunately, you can see that mine has gone beyond that. Okay, but I'm assuming that's the situation. So I'm going to have this. So I indicate. And whenever you are indicating points, please either you use this or you use circle dots. Don't use this. Don't use plus. Okay, and don't use, okay, asterisks as well. Immediately you bring in extra lines to make it asterisks. Okay, you move away from the exact point of contact, okay, or the exact point that you are looking at. And the more you move away from however letter point that you indicate and you move away, okay, it will move you from the allowed margin of error. So the human error will be huge. And therefore you go outside the allowed margin of error. So always use this. Okay, in that case, you can easily indicate, get the point of intersection, or use a dot, but don't end there. Use a circle dot. Circle the dots. Okay, so in this case, okay, I use this. Okay, then the next one, 19.5 gave us 38. So that one too, you come and indicate. You know the small box, what each represents. Okay, okay, this one will be 25. 25 will be midway. So you will indicate. You read and get the exact point. I want to put across a certain information. So now 29.5. 29.5 is giving us 78. So 78, you know, will be somewhere. Okay, so this is 50. This is about 100. So midway be 75. Okay, so 78 will be a little bit above this line. Okay, you know, 2 small boxes will be 10. So close to the second small box. Then you continue. I hope you are following.
Yes.
Okay, very good. Okay, so now we are going to have the next one is what 39.5. So this is 39.5 calibration, and that is 170. So 100, 150, 170, 175 will be midway. So that will be below that. So you come down. Okay, the next one, what do we have? Okay, 310, 300 is here. 310 will be 2 boxes after 300. Okay, the next one, what do we have? 400, 400 is exact. Okay, the next one, 450 is also exact. The next one, what do we have? 480. Okay, so that will be somewhere. Okay, this will be 475. Okay, so 480 will be a little bit above. Okay, 5 more, or 1 small box more. Okay, then the next one will be 500, and that will be, oh, have I left a point? It seems I've left a point out. Okay, because I thought this was supposed to be, let me count. 1, 2, 3, 4, okay, 5, 6, 7, 8. It's supposed to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've left 2. Okay, 1 is here, so I've left 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's supposed to be 10. So I left 1. Which one did I leave out? Okay, let me see. This one has its corresponding. This one has. Okay, or let me see. 170. Okay, which one did I leave out? If you were watching my back. 450, 69.5. Because I have not done the calibration, I'm not able to, but I can still make my point. Okay, so you will do the right thing. You get all your 10 points there. Then you join with your free hand. Oops. Okay, it seems I have to go and take my time and draw it well. Because if your curve is not flowing well, it will affect any question that you are supposed to use your curve to find. So you should pass through the point. I think it's better now. Okay, natural fight was supposed to end at this. This is rather this one that should give you the one, okay, the 500. Okay, so this will be the nature of your curve. Is my point well made?
Yes, please.
Yes,
Okay,
please.
so now every graph is supposed to have the axis label, which you have done that already. You're supposed to have a title. So here, what will be our title? Fedaios, let me know whether you got, okay, what I said for the histogram is the same thing. Okay, the same kind of, okay, way of what? Indicating your title. Is Prof. Fedaios around? You asked initially, let me see.
Yes, please.
Okay, so what do you think your title will be? I said, always go to the question. Let the question guide you. The question asks you to draw what?
A cumulative frequency curve.
Okay, but The cumulative frequency curve for what? For the Marx distribution. Is that okay for this information?
Yes, please.
So a cumulative frequency curve for the Marx distribution, as simple as that. So that is supposed to be your title. Okay, so a cumulative frequency curve. Okay, right. For the Marx distribution, you neatly underline. And your scale, if you have room here, let it come there. Is my point well made? Hello, is my point well made?
Yes, please.
Okay, very good. If that's the case, then this is what I want you to do. I'm taking the graph right away because I want to make sure that you have, I want you to see whether you all know how to draw the cumulative frequency curve so that in our next meeting, I will just give you questions that you will be asked to use your frequency curve to draw. Okay, I think maybe I can use that one as an assignment rather than, so do this one instead for me right away. Okay, where is the other one? There was one that I said, it's supposed to be your assignment for the histogram. Or I remember I said histogram, one question, I think it's this one. Am I right? Yes. Okay, so this is supposed to be your classwork. Everyone will take part. I realize that some of you don't submit your work. Okay, so we have about 30 minutes. I'm giving you 15 minutes, to have this one done. Maximum 15 minutes. After that, I will put the cumulative frequency curve that I want you to draw. Okay, then in our next meeting, we'll look at questions that you could be asked from the frequency distribution. Sorry, cumulative frequency curve, I should say. Okay, questions that will require the reading on the x-axis, the reading on your y-axis. So the reading on your max less than axis, which will be your boundaries axis, and the reading on your normal or your frequency axis, your cumulative frequency. Okay, so I'm waiting for your histogram. So I'm interested in the B and the C. However, you do the A as the last question. Okay, let me see how smart you can be. On this one, how smart. Please, you know that, there's a past question and you have past questions and solution. You have A+. Don't look at the solution. Just do it the way you understand. Is that clear?
Yes, please.
Don't give me any wrong impression, please. Okay, that will not be helpful to any of us. Okay, so on this note, we are bringing the curtains down on today's lesson. But please make sure you submit your work. Everyone is taking part. No one is leaving. Everyone must take part.